In this lecture, we are going to explore how we can set up freestanding non-member global operator functions and make them friends of our class template. That's going to be useful, especially if our operator functions need to access private data from our class templates, and we will be using the stream output operator as a use case here. So again, the reason we are doing this is because this will give us the ability to set up a bunch of operators. And this is really something you need to do a lot. So I picked up this little subject in our friendship exploration to class templates to really make sure you can do this. But note that this is not the whole story. There is still a lot about friendship and class templates, and I would be crazy trying to cover that in a beginner course like this. That's something really advanced. Maybe I will have a chance to cover this in later courses that I will do after this. But for now, we need to get the basics straight before we can move on to more advanced things. So let's do this. So some of you might start doing something like this. We have a class box container and we want to set up an operator, and this is something that is wired in our fingers now. We can set up a single operator like this, and this will be working on our box container object and trying to print it out, for example, to stdc out. We can do something like this. Once we have this, we can set up an implementation like this. This is going to be a function template. It is going to be taking our parameter. We will be saying what we want to print. For example, we can put out the size and the capacity. We can really do all kinds of crazy things. After this, we're going to be looping, printing each piece of data we have in our collection here. Notice that we are passing this by reference to avoid copies. This is something that should be wired in your brain now. And we're going to return an object of our stream object to allow operator chaining. So you have these things in your code and you go on and try to set up an object and print it out. And you're going to be surprised to have a bunch of undefined references, and this is going to puzzle you. Well, the problem is that the compiler is going to look at your box container class, and it is going to have no indication to tell it that this operator here is a template. So it will put this in as is, and this is really not going to be there because our operator is a template. We will really have an instance for int generated. So we need a way to help the compiler out to figure out that this friend function is the same operator we have in our code as a function template. You really need to understand this. This is really something we also saw in the last lecture, but I really wanted to make this super clear in the context of operators like the stream output operator here. So we are going to apply the same solutions we saw in the last lecture. You can help the compiler out by adding a pair of angle brackets and passing in your template parameter like this. This is going to tell the compiler that this is a function template, and it will generate a template instance for this that is going to match the template function we have for operator stream output. You can also put in a pair of empty angle brackets, and this is going to tell the compiler the same thing. This is going to work. So this is our first solution. It is to tell the compiler that our friend function is indeed a template, and we can use angle brackets like this, or we can put in a T here. This is going to tell the compiler the same thing, and our code is going to work. Another solution is going to be to set up your friend function inside the class and put the full definition in there. So the definition is not going to be on the outside. This is going to allow us to directly access private data in our object here. For example, we can use the syntax like this to access private data in this object directly. Notice that just because the function shows up inside the class, this is not going to make this a member function. This is still not a member function because if you try and access member variables directly, you're going to get a bunch of compiler errors. So this is just a weird arrangement C++ is going to give you to be able to set up things like this. But this is not a member function. This is still an outside friend function, but we happen to put the implementation inside our class. So C++ can really be confusing in this way. It allows you to do things that don't make any sense at all, but we have this. This is going to solve our problem. You can use this solution if you want. Now that you know this, we're going to head over to Visual Studio Code and explore this a little more. Here we are in our working directory. The current project is stream insertion operators for class templates. We will grab our box container class, the code for that living in our header and CPP file, and put those in here. You can grab these source files from the resource section of the lecture, and you will be able to reuse this exactly like I am using this here. And let's open this up in Visual Studio Code pretty quick by dragging and dropping here, and we will have our box container class. Now, the first thing we want to do is to set up a stream output operator that doesn't work like the one we had before worked. And let's make sure we see what we had in here. So we have a stream output operator, but it is going through public methods to get the data that it needs. For example, here we are going through the capacity method, we are going through the size method, we are going through the get item method. This is really weird. We don't need to do this. We want the ability to directly access member variables from this object without going through public methods like we are doing here. So this is what we want. So some of you might want to do something like this. Let's comment what we have here and set up an output stream operator that looks something like this. This is going to still be a function template, and you might attempt to make it a friend of your class using a declaration like this. And if we try to build our code, you're going to see that it is going to build. Let's make sure we don't have anything using this box container class. We can try to build our code using our favorite compiler. Let's use GCC to do that. And this is going to warn us of the problem that we are going to run into. It is saying if you are sure this is going to be a template, please make sure you add a pair of empty angle brackets to really solve this problem. You see, this is what we did in the last lecture, but the compiler is warning us of a possible problem we might run into if we try to use this class template here. Let's make sure we see the actual problem. So we are going to include box container, and we will create an instance for this for int. So let's say box container, and it will be for int, and we will say that this is an int box. We can do something like this, and we can add stuff. So let's say int box add. We're going to put in a 1. I think we can do this. And we're going to say int box and put in a 2. And we can try to print this out. So let's do this pretty quick. We're going to say int box, and we will put this out using our output stream operator. So let's say int box, and we will see how this works. So now that we have this in, we can try to build our code, and let's see what happens. This is going to blow up, and we will have a bunch of errors, and we will see that we have an undefined reference to this operator. And the reason is we are not telling the compiler that the operator here is a template, and this is the problem. If you want, you can learn a little more for this problem by going to this link here. We are going to see that they explore this problem in detail. So make sure you read this if you are interested. But the main problem is that the friendship declaration we have here isn't telling the compiler that the friend function we are putting here is a function template. And we can try and solve this problem by adding a pair of angle brackets here and have nothing in. This is going to tell the compiler that this is a function template, and it will link this function to the actual function template that we have down below here, and everything is going to work just fine. Notice that because this is a friend function, we are able to use member variables directly. We can access m size, we can access m capacity, we can access the pointer and use the array index operator to access data, and this is really going to work well. And we need the public accessors we had before to make this work. So we can take these guys out, and this is going to work really well. This is going to reduce the number of lines we have in our code. So let's make sure we build and see that this is going to solve the problem we had. We're going to pass this through our compiler. The build is going to be good and everything is going to work flawlessly. Let's bring up a PowerShell window and run Rooster. You're going to see that our data is going to be printed out, and this is what we want. Another way to solve this is to tell the compiler that our friend function is also a template by putting in a pair of angle brackets and putting our template parameter in. This is going to tell the compiler the same piece of information, and our code is going to work. Let's make sure we build this to see this. The build is going to be good. As you see here, we can clear and run rooster. Our code is going to work, and we will print this little guy. We also have another solution, as we have seen in the slides, and that is not putting in any implementation on the outside. So we can take this out completely and put the entire implementation inside our class definition. So we can go in our class definition here and put in the implementation for our output stream operator. Mind your steps, this is not going to make this guy a member function. It is just a weird arrangement we have in C++ to have this function have access to private member variables from an object like this. So we can access M size, M capacity, M items directly, but this won't have access to member variables directly without going through an object name. And this proves that this is not a regular member function. Let's try and, for example, increment M size directly and show you that this is going to give us a weird compiler error. This is not going to work. So let's pass this through GCC. And we will have a compiler error saying that M size is not accessible from this friend function here because it is really not a member. So you shouldn't do this. So let's take this out. And if we take this out and compile again, we will see that compilation is going to work fine now, at least I hope. So the build is good and we can run our program and it is going to work exactly as we want. We see our output data here. We can try and put in other pieces of data. For example, we can put in 10 and 20. We're going to add 10 and put in int box add and put in 15, for example. And this is going to do what we want. Let's build and see that this is working how we want. The build is going to be good. We can clear and run rooster. And this is going to put our data in and we can see all the data here. This is what we set up to do in this lecture. We are going to stop here in this one, and I hope you really found it interesting. Hopefully this gives you a good foundation you can use to set up operators as friends to your class templates. Make sure you put these little guys in, otherwise you're going to get a bunch of linker errors and you're not going to like that. We are going to stop here in this lecture. In the next one, we will learn about class templates with type traits and static asserts, and we're going to see how we can use these little tools to add the compile time checks to our class templates. Go ahead and finish up here and meet me there.